Hi everyone. In this paper and presentation, we are giving an overview about how operating system support for the DBMS. And here comes a quick overview or an introduction of this presentation. The DBMS designer must work on the context of operating system is faced with different operating systems are designed for different use. So in this presentation, I worked on like how to indicate whether the appropriate for support of database management functions. And often we all see a different services provided and different performance problems where exist. And we look at the services provided by buffer pool management and the file system scheduling process management, um, and how the validations and importance of operating system and how it supports for the databases. Here in this slide, it's a quick about and how the presentation goes on. Like in this presentation, we are going to study about how the traditional operating systems support the DBMS and how this paper written by Michael Stoneberg and Lawrence and was the new architecture they implemented to work on the new techniques and design of how it supports to the new methodologies and designs of operating systems to the modern architecture. And again, they also propose an architecture has influenced the design of modern database systems. Uh, Coming to the problem slide, like what exactly the problem addressed in this paper was like there are certain limitations of traditional operating systems in supporting the DBMS, specifically like not well suited to support DBMS of lack of necessary concurrency control and recovery process. And nowadays the data has been managed very securely authenticated techniques, and these limitations can result suboptimal performance and reliability of database management system has been very tough. And there is another problem like we have various domains like finance, healthcare, e-commerce. We need to maintain a large amount of data efficiently, reliably, and very securely. So uh, there should be a reliable support from the underlying operating system to ensure the optical performance and reliability of a management system. So, and these limitations can result in a subtopical performance where the traditional operating systems are not well suited for this latest modern architecture. And there is a hard problem because, like, if there are two complex systems with two different requirements and constraints, the novelty of the paper lies to proposers proposing a new architecture and allowing the optimizer architecture independently. So this approach enables DBMS to perform data management, concurrency control, and recovery more efficiently. Although it is possible to provide an OS buffer manager with the required features or exist at least with our knowledge, like the strategy used by most of the DBMS is like to maintain separate cache in the user space or within the space. So the buffer pool is managed by a DBMS specific algorithm to uh, analyze the problem easily. So, what exactly the importance of this paper is like the conventional systems included the file contained in the paper table within the file control block along with the buffer. And we can also schedule one-time buffers easily using the cache memory. As we all know, like there will be a lot of challenges facing with the modern architecture of the operating system concluded with the database systems. Like firstly, we see about concurrency control, how the primary challenges is supported in a database system, like ensuring that multiple users can access and modify the same data currently without interfering with the other data. And this requires implementing a mechanism of concurrency control, which can impact the performance of the system. And there is another problem like memory management. Like we all know, we have a large contents of data management and we serve a lot of data, we store a lot of data. And there might be the OS needs an efficient memory which need to be accessed necessary memory in the timely manner as a quick process. And we have a recovery management issue challenge. Like we all know, we randomly delete the data or we'll hide something like encapsulated the data. So at that time, we need a hardware failures or power outages or software crashes. So this requires implementing a mechanism of recovery management, which is a big challenge for the DBMS. And there is a file management challenge. Like the OS also needs to provide a file management system that can efficiently manage stored on disk and provide fast access to this data. And coming for security scalability, and we all know like we share a sensitive information and therefore the OS needs to provide security mechanisms to ensure that only authorized users can only access a particular data. And coming for scalability, the OS needs to be designed to handle large amounts of data with high levels of concurrency and performance. The main contribution of the paper is to propose a new architecture that provides better support for DBMS. The proposed architecture includes a component called Storage Manager, which sits between the file system and the DBMS, and then provides a layer abstraction that allows the DBMS to manage data more efficiently. The storage manager manages the allocation and deallocation of the disk space, as we all use a cache memory or a bucket memory to manage the store manager. And a store manager can also introduces a new transaction management, while we call it as write ahead logging protocol, which ensures data consistency and fast recovery in the event system of a system failure. The protocol requires all updates to the database to be recorded in a log before they are applied to the database itself. What exactly my approach on the evaluation of this paper was like, it separates the traditional operating system functions from the database management system functions and introducing a new storage manager component as we discussed in the main contribution slide. The proposed architecture the proposed architecture has the three layers: the traditional OS layer, the storage manager layer, and the DBMS layer. The traditional operating system layer provides basic services such as process management and memory management. The storage management layer, as we discussed, the data storage and the retrieval, as we need to uh, fix all the challenges which we discussed in the challenges slide. So there should be concurrency control and recovery and scalability of the operating system. And the DBMS layer consists of high-level services such as query processing, query optimization. Here comes to our last slide, like how the validation methodology works in this paper was. And this approach is primarily based on the simulations and the performances of the operating systems, which included the management system too. And the benchmarks were comparing the proposed architecture with traditional systems. The simulations show that the proposed architecture can improve the performance by DMS up to the 20% in some cases, but the benchmarks demonstrate that the proposed approach provides better support for the transaction management and recovery than traditional systems. The results show that the write ahead logging protocol, which we use in the which we use in the modern design of the architecture, it can reduce the time required for recovery by 80% compared to the traditional operating systems. And the validation shows that the proposed approach can significantly improve the performance and the reliability of the database. Thank you.